Hello, everyone. This is our fourth session in the EESSI Happy Hour sessions every Monday at 2. We are still in the topic series of how to access EESSI. Uh, just a quick summary of the past sessions. So in the first session, we covered how to access EESSI using CERN VMFS. In the second session, we covered how to access EESSI using the EESSI container script. In the third session, we covered different ways to access EESSI. And in today's session, we're going to cover practical considerations and recommendations for accessing EESSI. Today's session highlights. First, I would like to say that I guess in the beginning of the EESSI Happy Hour sessions, we were having 507 software packages available in EESSI. Today, we have 533 software packages, so almost 26 additional software packages and ongoing. I would also remind you that there is this hackathon session in the wake of Euro HPC User Days 2025, Thursday, 2nd of October in Denmark. So whoever is interested in joining personally or online, you can still join through scanning the QR code available on screen and registering yourself. Third point for today is manual selection of the EESSI software stack. As we have seen earlier, once you initialize EESSI, basically it will detect the CPU microarchitecture of the host system you are running EESSI on, and it will make the best optimized software stack from EESSI for your CPU microarchitecture available for you to use or pick up the software from. Today, we will see that there is also a possibility of manually selecting the available software stack from EESSI. So for that, I will be using I will run a quick demo using the same VM which we used in earlier sessions, which is called the Happy Hour VM. And I will first try to show you the CPU microarchitecture on this VM. So if I do ls CPU grep -i Haswell, which is supposed to be Haswell. And as you can see, it has an Intel Haswell CPU processor. So now I already have CVMFS available on the system. So ls/cvmfs software.easy.io. Basically, it should now, yep, it's showing you that it is already CVMFS is accessible and software.easy.io is also accessible. So I will try to initialize EESSI and see what software stack it will automatically load. So if I do source/cvmfs software versions init dash, as you can see, and we already saw this earlier, it detects that there is no accelerator on this VM. It also detects that the CPU microarchitecture is Intel Haswell. So it puts in the module path the EESSI software stack best optimized for the Intel Haswell CPU microarchitecture. So if I do module avail, for example, GROMACS, I will see that it is offering me the GROMACS versions available in the EESSI software stack specifically for the Intel Haswell CPU microarchitecture. In the next run, what I will do is I will use the same source bash script on the same VM, but I will be using the EESSI software subdirectory override variable to choose manually which software stack I want to load. So by doing this and executing the bash script, I will see the same output, so it detects that there are no accelerators, but as you can see here, it has loaded the Intel Cascade Lake software stack from EESSI. So now you might be wondering, why would I choose the Cascade Lake, or why would I manually choose other software stack? This option could give the administrators a better overview, or they can, for example, some system administrators or users even can think that some other software stack could be better performing on their system. So they can run checks, some software, or even use the generic software stack from EESSI to further compare the optimization we are offering. So this is for the demo. Back to the presentation. The fourth point for today that I will be covering is performance aspects of CERN VMFS. One aspect we cannot ignore in the context of software on an HPC infrastructure is performance. And that is the P in HPC, basically. So now I will be focusing on startup performance. And what is startup performance? It is the amount of time it takes until an application can start running. This requires not only the binary program of the application to be launched, but also all the files, libraries, and dependencies of the application software to be also available on the system. In this context, I will be focusing on three terms: the cold cache, hot cache, and the warm cache. The cold cache is the term used when none of the files required for starting a particular software applications are available in any of the relevant client-side caches. In this aspect, the client will be streaming the software from the Stratum 1 server to make it available on the system. Hot cache is when all files required for running a particular software application are already cached in a memory on the client system. Example, in the kernel file system cache. And the third type of cache I will be mentioning is the warm cache. And it is when all necessary files are available in the CERN VMFS client cache, which typically could be on the disk of the client system, but not yet available in the memory kernel for the file system cache. And as a result, if specific software application needs to be loaded and it's available in the client cache, it will then be transferred from the disk to the memory. Those three terms that I covered can really impact the startup performance of the software application that the user is trying to run. For more information about this, we can see the link below, and I will show you on the EESSI Docs. So here we can find more information about those three terms I mentioned: the warm cache, hot cache, and the cold cache, and how those three impact different file systems, parallel file systems, for example, if it's a GPFS or NFS or even Lustre. And finally, we can see some results when compared to CERN VMFS. So this is one of the key points that affects the startup performance of the application. Another thing that I will be covering today in the fifth point is SQUID proxies and Stratum 1 servers. So when a client wants to load or run a specific software application using CERN VMFS, first CERN VMFS will check the availability of that software and all its dependencies and required libraries within the CERN VMFS client cache. If it's not available, it will try to stream it from the Stratum 1 server. The EESSI project provides a number of geographically distributed public Stratum 1 servers that you can use to make EESSI available on your systems. But it is always recommended to have a locally set caching server, one or more few squid proxies within your local network. In that case, when a user tries to load or to run a specific software application, if it's not available in the CERN VMFS client cache, it will first try to search for it within the squid proxies that are local in your network. If you want to be even better protected against network outages and increase the bandwidth between your cluster nodes and the Stratum 1 servers, you can also consider setting up a local private Stratum 1 server that replicates the EESSI VMFS repository. This guarantees that you always have a full up-to-date copy of the entire stack available in your local network. So here is a figure on screen. You can see different, first you can see the Stratum 0 server where basically new packages get installed in EESSI. And then you can see surrounding it the Stratum 1 servers, which are replica from the Stratum 0 server. And then you can see the Squid reverse proxy servers. So basically a client within a cloud or HPC user can first, if there is a Squid proxy, it will try to search for the CMFS client cache, then the Squid proxy, and then Stratum 1 server, which basically is a replica of the Stratum 0 server. This also impacts the performance since it basically regulates the bandwidth that's available between the client and the next layer, that is the Squid proxy or the Stratum 1. The next point for today is site-specific considerations and configurations. So just installing EESSI is enough to get started with the EESSI software stack on a CPU-based system. However, additional configuration is necessary in many other cases, such as when enabling a GPU support on GPU-based systems, site-specific configuration, and tuning the MPI libraries from site to EESSI or to applications available in EESSI. To allow such site-specific configuration, the EESSI repository includes a special directory called host injections, where system administrators can install files that can be picked up by the software installations included in EESSI. This special directory is located in CVMFS softwareis.io host injections. And it is a CERN-VMFS variant symlink that is a symbolic link for which the target can be controlled by the CERN-VMFS client configuration. To show you what this is, I will go back to the VM and try to do ls minus -e/cvmfs software.easy.io. And you can see the host ejections is pointing to opt EESSI. In my client configuration, I didn't yet configure the host injections, and I don't have ls/opt/easy. So basically, that's why it's showing as a broken link. So once that is configured with the CMFS client, then you will have the option as a system administrator to do the modifications I just mentioned. And the final point for today, please at any time interrupt me if you have any questions. So I'm going on too many points today, and I'm trying to cover as much as possible and give you hints how to further tune EESSI for your environment. So one thing I missed also is for the Stratum 1 and Squid proxy in the past point, it's also available under the EESSI docs, and you can check for how to set up Stratum 1 and even how to check for how to set up a proxy for your environment. When setting up Stratum 1, we also set a small highlight of the requirements for a Stratum 1 server. So every information is provided under the Easy Docs, and also just ask your questions in the chat or interrupt me for any further info. And the last point for today is the known issues. And I do recommend easy users to always check the known issues, which is available again under the Easy Docs. In known issues, for example, there was an update for OpenMPI when using OFAD version 23.10, which led into some errors, and we set some workarounds. So when configuring the OpenMPI to better fit your environment, if you run into this, you can check this workaround. Also, we noticed something when using the GCC 12.2.0 with FOSS 2022b on Zen 4 architectures. So whenever you find something that's going wrong, always it is preferable to check the known issues under EasyDocs. So those are the information I wanted to provide for today. And also, just to let you know, this was the last session within the Easy Happy Hour topic for how to access Easy. Next week, we will be starting with a new topic series called A Peek Inside Easy Layers, where we will get to know more about different layers in Easy. Why we chose that specific topic? Because when later on we start explaining about how to build on top of Easy, we will see that it is important to know the different layers and how to connect to those layers. So that's the information I like to share with you for today. Let's check the chat, and please, again, feel free to interrupt me. If anyone has any issues with the recording, uh, I will stop the recording after checking the chat. So feel free to ask the questions without being recorded.
I was a bit late to the meeting, but I would like to ask something about the errata. Are there also any bugs or workarounds for 25 EC?
You mean the compat layer 2025.06?
Yes.
The compat layer 2025.06 is basically set, but the software being built on top of 2025.06 is still work in progress. So as far as I know, and please correct me, there is a GCC now available, but not the whole FOSS toolchain yet. So we are still not aware of any issues, and we are trying to make the toolchain available. And as far as we can see that something needs to go under the known issues, we will make it available so that site admins or easy users will have a knowledge about that.
Maybe I could add a bit. So when we build something, some things just build, yeah. So we are lucky, but also sometimes things don't build right out of the box. And then usually what we do is we don't just put them into known issues. We really try hard to fix issues by all kinds of means, looking at the repositories of the software, see if there's any known issue there. We see if we can maybe fix any issues. Yeah, well, maybe just convincing the build process to use, for example, libraries from the compat layer if they need that. And in the end, it could still happen that maybe we have to, for example, relax a bit the testing procedure so that we tolerate a few more errors. So, for example, when we look at PyTorch, then I think it runs about 200,000 tests or has so many tests. and I think we tolerate something on the order of 2 to 10 failing tests. Yeah. It could be that maybe, for example, I think for NVIDIA Grace Hopper, we saw a few more failing tests, so then we relaxed that maybe to 20 or so. And then we would put a known issue there that for this particular architecture, for this version of the software with that tool chain, we saw that issue.
Clear?
We also had a question from Georgios. So basically what I understood, you're using the variable easy architect options override to set the architecture. And should we switch to easy software? Georgios, do you mind explaining a bit of what you're trying to do? Or do you have an issue and why are you trying to set this override option?
It's similar to what you were describing. So we have a cluster with a mix of older and newer nodes, and we just want to provide a uniform software set for our users. So that it loads, we want them to load the same binaries in all kinds of nodes in this cluster. So we have to set the architecture to something fixed before loading easy. And it's a setting we set like 4 months ago. We found that this option uh, was able to fix the software side that easy load. So we switched to this new variable, which the software subtier override.
Mhm.
Sorry, can you say a little bit more about how you initialize easy? So how you
We use the module to initialize
okay,
easy. Uh,
yeah. Yeah, so it
uh,
could be that I think the easy software subtier override is used when you use this init bash script.
okay.
It could be that when you use the module file that you have to use easy architect options override. But the intention there is not to replace one with the other. It could be just that maybe different ways or different variables for different ways how you initialize easy.
Okay. Okay. Thank you. Thank you.
A question, since you said you have too many systems or different types of architectures, did you consider setting a proxy or Stratum 1 in your environment?
I think we have set a proxy. Yeah.
Mhm.
Uh, I don't know about the Stratum one. I can check with our system administrators. So yeah, I can check with them.
I'm trying to see how relevant today's session was with your environment and how we can further help you share more information about it. Yeah.
Okay, okay. Yeah, I can send you some more information. We definitely need to override the default architecture, right? So
Mm-hmm.
that was useful to see that it's, let's say, how it was intended to be used. So we do use this feature. Yeah, I can send some more information about how we set up our CVMFS.
Also, are you using, if you don't mind, if you mind, I can start the recording, Georgios.
No, no, I don't mind. Please go.
Also, did you further tune the host injections to fit your environment or?
No, no, that's what something we're planning to do. We haven't done that yet, but that's something we would like to do. So we want to compile, let's say, our own version of MPI and then inject it into the easy stack.
Mhm, mhm. Also, maybe again, I forget to mention more information about the host injections is also available under EasyDocs.
Yep. Yeah, definitely have a look. Yep.
Yeah, and as said earlier, so the Easy Happy Hour is basically we have a session, but any questions are welcome. So at any time, if you try something and it doesn't work, just prepare it for the session. And after the session, as we're having now the conversation, you can show us and we can further help you. Yeah.
Yep. Thank you.
Regarding the variable question, so maybe it's could be an interesting thing to do. That is, we just go over all our scripts module files and to see what variables we have and provide some information on that, looking at all these variables, what the intention of those variables are when they're used. Maybe is that a sort of user-facing, admin-facing variable, or more like internal for easy?
So, any other questions? For now, I will stop the recording, but you can still ask your questions.